Hello, and welcome to another video on IB stoichiometry. Today we're going to be looking at one of the very common questions in IB, which is to identify an unknown organic compound based on stoichiometry and the mass of carbon dioxide and water produced. So this is the type of question you're going to get. Once you know the method, it is very simple to solve. We've got an unknown hydrocarbon, so we don't know the ratio of carbon, hydrogen to oxygen. But we know in a combustion reaction that we form CO2 and water when there's excess oxygen. So what do we need to do first? We know that we produce 10.46 grams of carbon dioxide. And using this data, we can find out how much carbon originally comes from the organic compound. How do we do this? Well, 12 grams of carbon are present in carbon dioxide of the 44 grams per mole. So we can see how much carbon is in the compound by multiplying the overall mass by the ratio of the carbon to the overall mass of CO2. So we get that of that 10.46 grams, we have 2.85 grams of carbon. Again, I'm rounding up in these calculations to keep the digits low. The same logic applies for water. Two hydrogens have a mass of 2. So 2 out of the 18, the molar mass of water, is how much hydrogen there is. So if I do this multiplied by 5.71, this tells me that I've got 0.634 grams of hydrogen, which must have come from my original organic compound upon combustion. Now, since we know the mass of carbon and hydrogen, and we know the total mass of organic compound, if we subtract these numbers, we find out how much oxygen there's left. How much oxygen there is in the sample. And we get 1.276 grams of oxygen. Now that we know the mass of each element, we can use the technique of calculating empirical formula to find actually what is the ratio in the formula here, so the empirical formula. So we set up a table as usual. We put carbon, hydrogen, and oxygen. We divide by the atomic mass found on the periodic table. Again, I'm going to use the rounded up values to save time here. So 12 for carbon, 1 gram per mole for hydrogen, and 16 grams per mole for oxygen. Here I get how many moles of each element I have in the compound. So this many moles here. 634 for hydrogen and 0.07975 moles of oxygen. At this stage, what I need to do is find which one is the smallest number and divide all of them by the smallest number, which is 0.07975. And here again, I'm going to round up the numbers just to save time. I get 3, 8, sorry about that, 8, 1. So my empirical formula is C3H8O. That's my final answer. Thank you for listening, and hopefully this helps you solve these complicated problems.